Welcome to the Unit 3 Expressions Review. Thought this joke was kind of funny since we are simplifying expressions and a student asked, how come we never complicate equations or expressions in this case? Okay, remember your test is on Wednesday. This will be really just a mini test, only a few questions, and it shouldn't take you the entire period to take tests. So let's get going and start with question 1. For these first few problems, we are looking at writing an expression or an equation for each of the following written expressions. So in the first one says the number of notebooks in divided among 5 classes. This one's kind of easy because they use the word divided. So you could either write this as n over 5 or n divided by 5, but the n must come first because that's what you're dividing up. Okay, next it says 45 years less than Miss Cohen's age, A. Remember we talked about less than is kind of tricky because it has the number first, but it really means to subtract 45. So I would have Miss Cohen's age minus 45. Next, we have the question of the total points earned, P, and 100 points. So we have to remember that the word quotient means to divide. So this is actually what we do on your tests, is we do the points, P, divided by however many total points there are. Or you could write it as P over 100. Next, we have 27 is. We didn't talk a lot about is, but when you see the word is, think of equals. 27 is 3 fewer students than last year, and they gave us Y. So you could write this as 27 equals 3 fewer. There's that thing again where it's like fewer, less than, meaning to subtract 3 than last year. So that would be last year Y minus the 3 would give us 27. The product of 5 and Y added to 3 is 23. There's that is again. So we have to remember also what the word product means. Product means to multiply. So really this means 5y, which means 5 times y plus 3 is 23. Which of the following is a rule or an expression used to find the value of the term in the sequence below using the variable n? N being like what position you're at and how many there are of that term. So what I do is I look at each of the choices and I X them out as if they work or not. So n plus 0, if I try n plus 0 and I plug in 1 plus 0, I get 1. So it works for that first one. But then if I try 2 plus 0, it didn't work there. So that automatically eliminates A. Then I go on to 3n minus 2. So that would be 3 times 1 minus 2, which would give me 1, so it works for that one. And then 3 times 2 minus 2, 6 minus 2 is 4. Oh, it worked for that one too. 3 times 3 minus 2, so 9 minus 2 is 7. Oh, it worked for that one. 3 times 4 minus 2, 12. Yep, there we go. That one is 10. And 3 times 5 minus 2 is 13. So B is our answer. Take the time, check all of the problem, every single row in the table and make sure it works. Do not just check the first 2 because it could be later on that the pattern didn't continue the way you thought it did. Okay, this time you're actually having to write an equation or an expression from the relationship in the table without giving you choices. So remember, we need to look at how does it get from 1 to 12? Well, we could say it added 11, but then if you do 2 plus 11, that doesn't give you 24. So then you would think, okay, well, what about 1 times 12? And that gives me 12. And 2 times 12. Well, that gives me 24. And 3 times 12. So it worked through the entire table. So I would say 12n equals C. And always remember to tell us what does your labels represent. So this is my number of tickets. And C would be my cost. Or you could also do x and y. If you wanted to say 12x equals y, you could say, okay, x is my tickets and y is my cost. Okay, now you're writing an equation for each of the following graphs. There's going to be one on this, and then I'll do another. So we always want to look at what is the unit rate. So we can tell this is proportional because it goes through the origin, it makes a straight line. So that means if it's proportional, that 1, it's going to be multiplicative. And we could find the unit rate. So something some of you might do that may help you is actually write out the points. So say that I have 130, 260, 390, and then notice what is happening between 1 to 30, 2 to 60, and 3 to 90. Yes, it's multiplying by 30. So I could say 30x equals y, or if you want to, some of you like to do 30 times x, okay, and that would be the answer for that problem. So in this graph, it's a little different because they didn't give you points. But remember, you can find the points by looking at the corners. Like here's a point, it's nicely on the corner. This is not a good point because you don't know exactly where it's at. So you pick those points that are on the corners. Go ahead and color them in on your paper. Then I would make your table. So remember you have your x and your y. Your x always comes first. And I'm just going to count just same way, 2, 4, 6. And you don't have to put all of them down to get an idea. So I have 94, 188, and I have 282. Okay, so now I can't easily see what is happening here. Okay, you could make an educated guess. Some of you can see, but for the ones that maybe you're not sure, let's just divide and see if we can figure out what it's multiplying by. So 2 into 94 goes 4 times. You have 14, so that worked 47. But we want to check the other ones as well. So that one did give us 47. So let's check and make sure the other ones will also give us 47. So if I do the same thing with the 4, I get 16. Okay, that one also gave us 47. So it looks like 47 is going to be our multiplier that we're looking for. So double checking one more time, make sure that it does work, and look, perfect, it did. It gave me 47. So that tells me, 1, it's multiplicative, and it's proportional. We should already know that because it's going through the origin, it's a proportional graph, it's linear. So that would make my equation y equals 47 times my x. Next, we are evaluating the expressions given known variables. So for this first one, we have 2a plus 4b divided by 8. And I know some of you can do this in your head, but I highly recommend, especially on the test, work it out in case you do a mental mistake. Take the time to let me see what you're thinking to make sure you are correct. So 2 times 10 is 20, plus 4 times 3 is 12, divided by 8. Then you have to finish your order of operations. You'll get 20, plus then you have to do 12 divided by 8, which will go in there one time with 4 8s left over, or 1/2. You add those two together, you'll get 21 and a half. Okay? So that would be 21 and a half for this problem. So I'm going to scoot this over actually, put it down here. Next I have d over t, the letter t, plus 10. So I would put 600 in for d and 50 in there. So that would give me plus 10. So we have to divide first because of order of operations. Would give me 12 plus 10, which will give me 22. So the second answer is 22. Nathan gets paid $12 an hour at Walmart. Complete the table by using the scenario above. So in 1 hour, I know that he makes $12. Whoops. Okay, then for 2 hours, he'd make 24. 3, he'd make 36. 4, he'd make 48. So we notice this is a multiplicative relationship because it's multiplying by 12 through the whole entire thing. Okay, we also know it's proportional because it's multiplicative. So then it says for us to identify the independent and dependent variables. So remember, independent, it stands on its own. The hours in this problem stand on their own because they choose how many hours they're going to work. Well, kind of. They choose whether to go to work or not. So they're choosing how many hours they work. And then the money is dependent on how many hours Nathan actually works. And then it says, write the expression using the table above. I know this is just like one of the problems we already done. I didn't realize it till after I already made copies. But once again, you could define your variables. So if you're going to use H, say H is hours, and M is your money. I always like to use X and Y just because if you're graphing, we use X and Y. So this could either be 12H equals M or 12X equals Y, whichever variables you chose to use. Mr. Diaz changed his shower head to conserve water and energy. The graph below shows the relationship between the amount of flow and the duration of the water flow. So, how much would you use in 12 minutes? So this time we're having to find our equation to figure out how much you would use in 12 minutes. So once again, this one doesn't have points, so you're looking for that mark. So if you're looking right here at this 1, you're kind of not 100% sure if it's really halfway between 0 and 5. So to check that, we're going to go actually over to 2 and put a point there because that is hitting on the line. Also, you can see exactly at 4 and 6. Those are all good points to use. So once again, you could also make your table if you wanted to help you with this problem. Some of you might actually just work it out in the table because you'll notice a pattern that 2 was 5, 4 was 10, 6 is 15, and then if you kept going, you saw 8 was 20, 10 you can see is going to be 25, and then 12 would have to be 30. But if you didn't see that pattern like that, you could have also found the equation. So you could have done the 5 dividing 5 by 2. So 2 will go in there twice, 4. Some of you have this memorized, but just in case. So that gives me 2.5 because think half of $5 is $2.50. So I could use the equation y equals 2.5 times x. So that would give me y equals 2 5/10 times 12, which will give you y equals 30. So either way, whichever way works for you, use that way. If you can use the pattern from the graph, that's awesome. If you need to write an equation, write your equation. Remember, there's more than one way to solve the problem. Okay, on to some of my favorite types of problems, simplifying expressions. So remember we talked about a way to help us is to break apart into terms. So we're going to break each term up, and then we're going to circle like. I'm going to use different colors. So these two are alike, and those two are alike. So if I combine 3x plus 7x gives me 10, and then 19 minus 10, oh, sorry, I forgot my x, 10x, 19 minus 10 would give me 9. So that would be the simplified version of that one. Once again, we're going to break these terms up. It helps us see them as individuals, and that is what we want to see. Okay, so I'm going to look for all of my a squareds. Remember, they have to have the base and the exponent the same. And here's another a squared. So 2a squared plus 5a squared would give me 7a squared. So now I'm going to look for 3b's. Oh, there's an 8b. So 3b plus 8b would give me 11b. Next, let's pick a different color, okay? My minus 2b squared and 6b squared. So you kind of have to think 6b minus 2b, that would give me 8b squared. And then the 4a is all its lonesome. So most teachers in high school, college would want this written in alphabetical order and in order of the highest exponents. So this would be 7a squared plus 8b squared minus 4a plus 11b. If you didn't write it in this order, you're not wrong. I'm just showing you what your future math teachers are probably going to be looking for. Okay, now we're looking at distributive property. Remember, we are distributing to everything in the parentheses. Do not go beyond the parentheses. If it's not in the parentheses, it does not get distributed to. So I would do 4 times 3, which gives me 12x, and 4 times y, which gives me 4y. Then 8 times 2x, which gives me 16x, and then 8 times 5, which is 40. Next, you need to check and see if there's anything that I can combine. Well, I noticed that I have an x and an x, so 12x plus 16x gives me 28x, plus 4y, plus my 40 would be my final answer for that problem. Remember, simplest form. Okay, next we have 6 times 4z, which is 24z. 6 times 2y, which is 12y. And then, remember, it doesn't matter what side it's on, you're still multiplying. So here I'm going to 6 times 2 again, 6y times 2. And then, oh, I ran out of room. Minus the 6z. Okay, actually, I'll make it neater. Can't deal. Okay, 24z minus 12y plus 12y minus 6z. There we go. So once again, breaking this up so we can look at them separately. So I see 24z minus 6z would give me 18z. And then I have 12y minus 12y, which is 0, so 18z would be my final answer. Okay, we're looking at finding equivalent expressions. So we have to think, what does the word equivalent mean? It means they are the same, they are equal to one another. They represent the same thing. So the first thing I would do to find if they are equivalent is solve these into simplest form, because that'll truly help you determine that. So we have distributive property again. This would give me 8x plus 12. This one would give me 20x plus 16. I can already tell those first two are not equivalent to each other. This next one, I have 4x plus 6 plus 4x plus 6. And then we have 20x plus 16. But this one right here, I can make smaller because we have our x's can be combined, which makes 8x and then plus 12. So if you notice, you can say that 4 and 2x plus 3 is equivalent to 2 and 2x plus 3 plus 2 times 2x plus 3, because they both simplify to the same. But you could also say that 2 and 10x plus 8 is equivalent to 4 times the quantity of 5x plus 4, because they both gave us the same thing as well. So, because this answer is the same as this answer. So remember, to explain how you can determine if they're equivalent is you need to get down to simplest form and prove that they represent the same quantity. Well, that's it for this review. Study. Don't take long to study for this. You know this. We've been working on this for several weeks. You'll do great. Good luck tomorrow.